Okay, please come to the pitch stage to hear the 5-minute pitch from Team UppSense from Sweden.
Hello, everyone. So, my name is Anna, and I'm a member of UppSense, the Uppsala University team. So, I would like to explain you, we come from Sweden, and we come with this device. Quite small, nice, dark, but what's the principle behind that? So, it's based on sample antibodies mixed together in a cartridge, and this cartridge is put into a reader, this reader. This is common in most of the biosensors. But then what it makes different in our case? Our assay is based on a pair of antibodies together with quantum dots and magnetic beads. This is a standard representation of an antibody where we have a recognition area specific for proteins, and at the same time we have another region that helps us to conjugate those antibodies with quantum dots or other particles. And then, why are we using a pair of antibodies? Well, an antibody is quite specific and recognize particles with high efficiency, but they are not perfect. Sometimes they recognize proteins that they shouldn't, and at the end, this is translated to quantification of proteins, other particles that we don't want. This would be a wrong result. By using a pair of antibodies, we make sure that those chances are less, and the protein we are quantifying is the one we want. Magnetic beads, just a simple question. If you have a mixture with salt and iron particles, how would you separate them? We will use, well, sorry, now it's not working the video, but we would use a magnet, is it? So this is the same principle we use in our assay. We conjugate those antibodies with magnetic particles, and this helps us to separate between free antibodies from the antibodies that are bound to the anti-proBNP. Quantum dots. Have you ever heard about those quantum dots? They are really common and are being developed in screens and TVs because you can achieve nice resolutions and nice colors with them. They consist of small particles in the nanometer range. And the good thing about them is that they emit light and a specific color depending on the size they have. We use quantum dots to quantify the amount of anti-proBNP we have in our sample. And as I said, all this mixture, the mixture with antibodies and this anti-proBNP happens in a disposable cartridge. This cartridge mixes and captures the antibodies, and at the same time, it provides the interface to put it into the electronics to the reader and get the signal. This cartridge consists of a reaction chamber where the mixture happens, and also the detection chamber. Those are connected with a fluid channel, and everything to a pump. This pump allows us to form mixing in the first area by forming bubbles. And once these bubbles and the mixture is done, we stop, we switch the function of the pump, and then instead of pushing the air and making bubbles, we transport the solution from one chamber to the other. Once this is done, we take this cartridge and we introduce it to the reader. The reader is part of the engineering work, which consists and deals with the fluorescence and digitalize the signal we get and quantify it and get the anti-proB concentration. As I said, we are using fluorescence as a signal. This signal comes from the quantum dots, and the requirement they have is that they need to be irradiated with a specific light. This light we are using is in the UV range, and the light they emit is in the infrared. And since we want to detect signal light, we need to introduce this cartridge in a dark box. Then the only signal we get is the one coming from our sample. And even to increase and make sure that we are not getting signal from other sources from the outside or connections between wires, we don't use any cable between the inside and the outside. We make use of Wi-Fi module. At the end, the software translates the electric current, the signal we get from electronics, to an anti-proB concentration, and a correlation between anti-proB concentration and the potential. This is what we translate, and we send it to a smartphone, to an email, or to the doctor. So this is our biosensor. And if you want to have a look closer and ask any questions you want, please come to our stand. So we will be glad to answer your questions. Thank you so much for your attention.